and welcome to this video. My name is Carlos, but you can call me Cali. In today's video, we are going to cover server-side request forgery attack. First of all, we are going to explore the concepts of SSRF. Then we are going to move to the next section where we are going to understand how this kind of attack works, as well as create our own attacks. And finally, we are going to cover some prevention techniques. So let's get started. First of all, what is server-side request forgery? This is a type of security vulnerability where an attacker can make the server perform unwanted actions, where the attacker might make the server connect to internal-only services within the organization or force it to access arbitrary external systems. So let's take a look at this example. Let's say here we have John, who's going to submit a building inquiry ticket through the support platform's web form reported a charge discrepancy. So what John's going to do, he's going to visit streamsites.com/help. Then the server will process this request, following by John entering some information to the submit invoice form. The user is going to share, for instance, the full name, the contact number, an account number, and the invoice number. Once this action is performed, then the server will retrieve this information in JSON format, as you can see here in the image. Once the server processes that information, then the company, let's say this utilizes a third-party system for billing to authenticate the validity of the invoice. So the system, once it received the information from the user, it's going to use the third-party system to confirm the invoice number. Then it's going to visit the user of the company to the URL billingsupport.net billing and the invoice ID, which it will provide the invoice number. By the way, all of this happens in the back end. It's not like someone at the company will send an email to the third-party system and they will process the request. Most likely they are going to have a specific system for invoices and for billing. So once the server has processed the request, it's going to confirm the invoice, it's going to make the validation. And once the validation is made, the server will create a support ticket for the user, which will be delivered to John in this case. It's been created as a support ticket. And now how can an attacker can actually take advantage of this platform, of this service? So what the attacker may do, they could submit a request pointing to an internal service or a local network source. For instance, localhost that slash admin, where the attacker will provide some information and the URL pointing to an internal service, in this case to localhost slash admin panel. What the attacker could also do, they could redirect the attack to a specific server, an internal server facing the internal network. So now let's go and perform this kind of attack. So if this is optional, first of all, if you want, you can sign up for a free account at PortSwigger, and then we also are going to need board suites. So first of all, you come here to PortSwigger.net. If you don't have an account, you can create one, or you just simply log in. Once you log in, you will be displayed in this page. You can click on Academy. Then we are going to go to all content, all topics. Here you're going to find different topics based on web application security. So we have server-side topics and client-side topics. On this video, we're going to focus on server-side request forgery. We're going to click on the link So here we have all the information that I already shared with you. We are going to click on view all SSRF labs. Then we're gonna go to the next section, and here we're gonna find some exercises. We're gonna click the second one. So let's go and open the application. So here we have the lab actually, basic SSRF against another backend system. So here we have in a lab that has a stock check feature which fetches data from an internal system. It's going to be similar to the server that we had before. For instance, here we have our third-party systems where the company will confirm the invoice sent by the user, in this case by John. As you can see here, this is how this works. John sent the information, the server processed this information in JSON format, then it validates the invoice or the information provided with the third-party system. It's going to be kind of similar here. We have a store that we want to check the available items that are in stock. So let's exit the lab. We are going to open PortSwigger. There we go. So let's go and check here the lab. We're going to click OK. So here, this is our lab that we are going to working on. We have PortSwigger, and we're going to click next, start work. And now let's gonna go and take a look at the website. So here we have, we like to shop. Whenever you click on any of the items, view details, it will display some information about the products. This is PortSwigger. So here we have some information, the description, and check as stock. So here the website is using a third-party system where it's going to confirm if an item is available or not. So we're going to turn on our intercept. We're gonna turn on Foxy Proxy on PortSwigger. Okay. Now, oh, sorry about that. Then we're going to check the stock. We're gonna click on the bottom. This is information that it will load before. Okay, so here we have our post product stock request. Oh, we're going to forward intercepted zone. We're gonna go to HTTP history. Now here we're going to click on the post method, the URL product slash stock, right click. We're gonna send it to repeater. Then here in our repeater, we can start our analysis. So first of all, the method that we are using here in this website is post. The route is product stock. Here is the host or the domain name. And here we can see that a session cookie was created. And here we have our stock API that it's going to retrieve the information about the available items. For instance, if we send this request, we can see that it'll display the available number of items, that it's 697. But now let's decode this URL. We can use Ctrl+Shift+U to decode the information and take a look at the information that we have here. So as I mentioned before in our example, here the attacker will try to access an internal network via facing web application. So here the attacker could submit a request pointing to an internal service, in this case localhost admin, in order to access the admin page. So we can try to access a local network. We can select local host, and then let's see what happens if we send this request. As you can see, it displayed some information. In this case, it says the internal server error couldn't connect to external stock check service. But let's go back to the exercise and let's read the information that we have in our lab. So here we have this lab has a stock check feature which fetches data from an internal system. To solve the lab, use the stock check functionality to scan the internal 192.168.0.8 range for an admin interface on port 8080, then use it to delete the user Carlos. So first of all, we have to find here the network that we want to attack. First of all, so we can go back here and display the information from here. What we are gonna try to do is the following. So here we're going to try to access first of all the admin panel, but here we have to figure out the internal IP address. So here we could do 192.168.0.19, and then we can send the request, and it says that it's a missing parameter. Then we can go and type the number 2 again, and we can play around until we discover some kind of information. So to save us time, what we are going to do is we are going to right click. We're going to send this to intruder. So here in intruder, we are going to select the last octet. And here we're going to click on add. Here in attack type, we're going to leave it as a sniper. Then we're going to move to payloads. So here, instead of simple list, we're going to click on numbers from 0 to 255. And then we can actually start our attack and see if it finds the the URL or the internal network where we can perform our attack, which in this scenario will be to delete the user Carlos. So here what PortSwigger is doing is testing all kind of IP addresses within the 192.168.0 range. So here what PortSwigger is doing, it's adding 1, 2, 3, 4, 5 up to 255. So now let's wait for a couple of minutes. So here you can see that the response in the length is all similar. However, we are going to see one that it's going to differ from the other responses, the same as the status code. It's going to be completely different. Meanwhile, we can go and see our application and review what we've done so far. So if we go here, sorry, to positions, let's go to repeater. So what we are doing here is we are testing this URL, this route with the method post. We are going to try to access the product that stock. And here on the stock API, what we are trying is to redirect our request to the admin panel. Let's go back to our PortSwigger. Let's click on the status code to see if there is some kind of information. As you can see here, we have a different status code, which is 200, and the length is also different from the other responses. So we can assume that in the range 192.68.0.22 is our admin panel page. So let's replace this information here. So we're going to type the 22, then we are going to send the response and see what we have here. As you can see, we have a 200 response that displays all the information about the admin panel. As you can see here, now we have admin panel, we can see the users, and we can perform relevant actions such as delete an existing user. So what we have to do now in order to solve our lab is to find the URL that will allow us to delete the username Carlos. So here we are going to copy this information, this URL, then we're going to paste it, and then we are going to send the request. So as you can see, 302 response, which most likely means that it worked. So let's confirm if we were able to delete the user Carlos. So we're going to go back to admin. We're going to send a request. Let's click on render. And there we go. We solved the left. And now the user Carlos has been removed. So great. That's the first example that I have here for you guys. So now we can close this. We can discard and we can go back to the last sections. So we have solved this first lab. But now let's go and try a different one. So here we are going to use this kind of attack, SSRF with blacklist-based input filter. So many companies will try to protect their internal network by creating some kind of filters or doing some input validation and sanitization. So here let's click on Access Lab and let's see what we have to do in this scenario. We're going to click on Proxy. We can actually clean the history. Yes, so we want to clean it. Intercept. Oh, then we got an error. Then just turn this off, disable this Foxy proxy so it can load our website. So now this is our second exercise. As you can see, it's the same web application we like to shop. If we click here on view details now, we can still see that we have check stock. So now what we are going to do is we are going to turn on the intercept. Here we're going to click on check stock. We're going to go to PortSwigger. Oh, sorry. First of all, let's enable Foxy proxy. There we go. Now we can send intercept our request. Sorry. And we can click forward, turn off the intercept. We can go to HTTP history. Here is our request. We are going to right click and send it to repeater. So if we send our request, as you can see, it's going to display the number of available items. But now let's decode our URL. So Control-Shift-U. And this is what we actually have. Now let's go back to the exercise and let's take a look at what we have to do. So this lab has a stock check feature which fetches data from an internal system. To solve the lab, change the stock check URL to access the admin interface at localhost /admin and delete the user harmless. The developer has deployed 2-week anti-SSRF defense that you will need to bypass, okay? So first of all, we are going to try this to access the internal network, localhost/admin. So here, what we are going to do, we're going to remove all of this. We're going to type localhost/admin and see what we have. When we send these requests, we get an external stock check blocked for security reason. What this is doing, it's blocking different kinds of requests based on the URL parameters that we are entering. So now what we can try to do is we try to use a different kind of localhost, for instance, 127.0.0.1 and see what happens here. Let's send this request. The same as the previous response, we get an external stock check blocked for security reasons. Now what we are going to try to do is we're going to try to use a different kind of request based on localhost. So we are going to type 127.1 and then we are going to send our request one more time. As you can see, now we have a 200 response. Let's take a look at what we get. So here now we can see the admin panel, home, and my account. So what we have to do is to find the admin URL. So as you can see, it's only /admin. So we are going to add admin and send the new request. Now As you can see, it's blocking one more time our request based on our parameters that we have provided. So now what we have to try to do is to encode some of the information in our URL. For instance, here we're going to encode the A, the first letter of admin. So we can right click and then we can go to where is URL. We're going to try to convert this section to URL. Then URL encode all characters. Then we are going to try to submit the request one more time and see what we get. It's the same response. So let's try to encode the URL one more time. So we double encode our request. Now we have this new generated encoded URL. Let's send it. And there we go. Now we can access the internal network and we can actually see the admin panel where we can delete the users. So let's go and check for the URL for username Carlos. So this is how we can delete the username. We're going to copy this URL, then we're going to paste it, and then we're going to send a new request. And now it says invalid external stock check URL illegal character inquiry at index 43, and it tells us that we have added here some semicolons and that we, sorry, some quotes here. Single quotes and double quotes. Now it successfully worked. Let's remove this section and go to admin one more time. Let's click on render and now we can see that we have successfully deleted username Carlos. So let's go and do one more exercise. So we have solved this exercise with blacklist-based input filter. Now let's go back to all labs and try one more. This is going to be an expert level. So let's take a look at it. Let's click on Access Lab. So now let's go to PortSwigger. Let's close this one. Go to proxy. Let's clean our history. We're gonna clean it. Okay, intercept, it's off. So that's perfect. So here we have our new lab. It's the same website, the same web application. We're going to click on view details to see what we have now. And as you can see here, it's exactly the same. Now we're going to turn on the intercept. We're going to enable Foxy Proxy. Now we're going to click on check as stock. We intercept the request, click on forward, then we turn off the intercept. Now let's go to HTTP history, right click, send it to repeater. You can do it from here if you want, send it to repeater. There we go, let's send this request and see what we get. So here it's displaying the available items, the number of available items. Here is our stock API. We can decode the URL, Control-Shift-U. Perfect. So now we are gonna try to do the same as we did it before. First of all, let's try to replace it by localhost and let's see what we get. Now, as you can see, we get external stock checked host must be stock that we like to shop.net. So here, what the application is actually doing, it's only allows some inputs that match a wide list of permitted values. So the filter here may look for a match at the beginning of the input or contain it within it. So let's go back to the previous URL that we have here. So what the application is doing, it's validating that the request starts with a stock that we like to shop.net. So what we are gonna try to do is to bypass this input filter. So what we can do here is we are going to be able to bypass this filter by exploiting inconsistencies in URL parsing. So first of all, for instance, we can embed certain credentials in a URL before the host name. Let me show you how we can do this. So we can delete this information right here. And here what we can do is, for instance, pass some credentials. For instance, let's say password at stock that we like to shop.net. We are going to send the request and see our response. So if we go to render here, now it says that we couldn't connect to external stock check service. As you notice, it's different from the previous one that it was saying that we can only have to use a stock that we like to shop.net. So now what we can try to do is that we can use the hash character to indicate a URL fragment. So we can do is the following password, and here we can add the hash sign and send the request one more time, and let's see the response. As you can see, now we get the same response as in the previous the first example. So here we have a stock that we like to shop.net. So now what we can try to do is that we can URL encode characters to confuse the URL parsing code. So for instance, here what we can do is we can go here to the hash signed, and we can use Ctrl U one more time and one more time. So we are going to double encode the hash character. And here, instead of using a random credential, we are going to use local host. And now we're going to send our request. So now we can see that our request was successfully proceeded. And now we can access the admin panel, as you can see here. So we're going to search for admin. We can see that it's slash admin, the URL. So we are going to send it one more time. Let's see the response. Now we successfully accessed the admin panel. So now we only have to delete the username Carlos. So let's go here. Let's search for the URL path. And here we have it's slash admin slash delete username, and the parameter username equal to Carlos. So we're gonna paste it here. Oh, sorry, I forgot to add the slash. Okay, there we go. Now we send a request and we get 302 response, which means that it worked. Let's check it by visiting slash admin. We can click on render, and we successfully deleted the username Carlos. So this is how SSRF works. And now we only have to learn how to prevent these kind of attacks. First of all, input validation and sanitization. As you remember from this exercise, let's go back here. Let's go back to the first request. Let's see it. So this is what we have first. So here, what the application was trying to do was trying to validate the URL provided. When we ask for localhost, as you can see, it's validating that the URL or the host must be a stock that we like to shop.net. However, we were able to bypass this filter by adding some URL encode and by passing some extra information to the URL. So what we should have to do to prevent this kind of attack is to make a validation of the user input and sanitize their input so they do not, if you remember, we were able to encode the hash symbol. For instance, here, let me do it one more time. So here, for instance, if you remember, we were able to perform this encoding. So here we have what, and here we have the hash sign, and then we did Control U and Control U. So here, what we could do is to create a regular expression that will block this kind of requests. Then we can use a network segmentation so that only authorized IP addresses can access the resource that we are trying to access. Then we have to follow the least privilege principle, which means that we are going to grant users, systems, and applications the minimum permits or access to the resources based on their functions. And then response handling, so how the application will manage the response in our headers. And finally, use security libraries and frameworks. So thank you for watching this video.